All right, in this section, we're going to talk about section 2.7. Well, in this video, we'll look at 2.7, wrap up chapter 2, dealing with marginal analysis in business and economics. And in this video, we're going to find the marginal cost, revenue, and profit functions. We're going to find marginal average cost, revenue, and profit functions, and also solve applications involving cost, revenue, and profit functions. All right, so first of all, we'll talk about marginal cost, revenue, and profit. Now, keep in mind that marginal refers to an instantaneous rate of change. That is a derivative. So basically, we're still dealing with derivatives here, but here we're going to be looking at how that's applicable to finding marginal costs and also marginal revenue and profit. So here's the definition. If X is the number of units of a product produced in some time interval, then the total cost would be C of X. The marginal cost would be just C prime of X. That's the first derivative. That's the derivative of your total cost, would be your marginal cost. And then if X is the number of units of a product sold in some interval, then your total revenue would be R of X. The marginal revenue would be just R prime of X. That's just the derivative of your total revenue. And then if X is the number of units produced of a product produced and sold in some time interval, then your total profit would be just this, P of X equaling to R of X minus C of X. That's the revenue cost minus the cost. Revenue minus the cost will give you the profit. Marginal profit would be this, P prime of X. That's the difference between the marginal revenue and the marginal cost. You'll subtract. All right. Now, marginal cost or revenue or profit is the instantaneous change of the cost or revenue or profit relative to production at a given production level. Now, here we're going to assume that C of X is the total cost of producing X items. Then the exact cost of producing the X plus first item is this, C of X plus 1 minus C of X. What that means here is this. When you find the exact cost of producing one additional item, we use this. Then the marginal cost is an approximation of the exact cost. That'd be C prime of X is approximately equal to C of X plus 1 minus C of X. And C of X plus 1 again is representing the cost of producing one additional item after X number of items have been produced. All right, so let's look at some examples here. Then we'll go into more detail about the things that I just got through talking about. Now, in example 1, you're going to find the marginal cost function. Here you got the cost function, C of X is equal to 180 plus 7.2X minus 0.02X squared. So when we find the marginal cost function, we just taken the derivative of the cost function. So for each term, we take its derivative. The derivative of 180, like the derivative of a constant, is 0. The derivative of 7.2x, that's just going to be that constant itself, 7.2. From minus 0.02x squared, we bring the 2 down, multiply it by minus 0.02, that will be minus 0.04. Copy that x down to the 1 less power. So the x to the 1, or just x. So your C prime of X, or your marginal cost function, will be 7.2 minus 0.04x. Example 2 is finding the marginal revenue function. Here we get x times the quantities 27 minus 0.09x. In this case, we need to distribute that x over the 27 and the minus 0.9x, and then take the derivative. So r of x is equal to this. X times 27 will be 27x, minus x times 0.09x will be 0.09x squared. And then we take the derivative to find the marginal revenue function. So r prime of x is this. The derivative of 27x is 27 minus the derivative of 0.09x squared. We bring the 2 down, multiplied by 0.09, that would be 0.18. Copy the x down to the 1 less power. It'll be x to the 1 or just x. So r prime of x, or your marginal revenue function, would be 27 minus 0.18x. Okay. All right, here's the next example. Find the marginal profit function if costs and revenue are given by C of x is equal to 179 plus 0.6x, and R of x is equal to 2x minus 0.05x squared. All right, so first we have C of x is equal to 179 plus 0.06x. Plus 0.6x. Now let's find its marginal cost. Let's find the marginal cost function, or C prime of x. The derivative of 179 is 0. The derivative of 0.06x will be 0.06. And now we have the revenue function, R of x is equal to 2x minus 0.05x squared. So to find the marginal revenue function, we take the first derivative. So the r prime of x is equal to this. The derivative of 2x is 2, minus the derivative of 0.05x squared. We bring the 2 down, multiplied by 0.05, it'll be 0.1. Copy the x down with the 1 to the 1 less power, so 2 minus 1 will be 1. So r prime of x will be 2 minus 0.1x. That would be your marginal revenue function. We also know this, that p prime of x, that's a marginal profit function. That's going to equal to the difference between your marginal revenue, r prime of x, and the marginal cost. So now we just substitute p prime of x will be equal to this. R prime of x was 2 minus 0.1x minus c prime of x, that's the 0.6. So now if I do 2 minus 0.6, that will be 1.4. But here I'm going to put the negative 0.1x in front, and then plus 1.4. So this represents the marginal profit function. P prime of x is equal to negative 0.1x plus 1.4. Okay. Here's another example. Let me bring this down. The total cost in dollars of producing X food processors is C of x is equal to 1800 plus 90x minus 0.6x squared. And he'll want to, in part A, find the exact cost of producing the 21st food processor. Part B is to find or use the marginal cost to approximate the cost of producing the 21st food processor. All right, so let's start with part A, finding the exact cost of producing the 21st food processor. So here in part A, we're told that C of x plus 1 minus C of x, that would be your exact cost. Okay, and that comes from this right here. The exact cost of producing the x plus first item would be this, C of x plus 1 minus C of x. Okay. And we got x plus 1, that's the 21st food processor. X plus 1 would be equal to 21, which means that x has to be equal to 20. So we need to find two things: the cost for producing 21 food processors and the cost for producing 20, using this formula or that function, the cost function. So we substitute each x with 21 in this case. We'll start with that. So the 1800 plus 90 times x, which is 21, minus 0.6 times x, which is 21, and that would be squared. So using the calculator, we got 1800. Let's clear this whole thing. I'll start from the beginning. 1800 plus 90 times x, which is 21, minus 0.6 times x, which is 21, close parentheses, and then hit x squared to square it. Then hit enter. This will be, in dollars and cents, $3,425.40. This represents the cost for 21 food processors. Now, for producing 20 food processors, use that same formula, but this time replace the x with 20. The same function will replace the x with 20. So in this case here, 1800 plus 90 times 20 minus 0.6, and then 20 in parentheses squared. This gives us $3,360. All right. So now to find the exact cost, that's going to be the cost of producing 21 food processors minus the cost of producing 20 food processors. The cost of producing 21 processors was $3,425.40 minus the cost of producing 20 food processors. That was $3,360. So if we subtract those, 3425.40 minus 3360. There we go. $65.40. So that means the exact cost of producing the 21st food processor is $65.40. That would be the answer to part A. Part B is to use the marginal cost to approximate the cost of producing the 21st food processor. So to find the marginal cost, that's where we take the derivative of this function, that's c prime of x. So c of x is equal to 1800 plus 90x minus 0.6x squared. Let's take its derivative. The derivative of 1800 is 0. The derivative of 90x will be 90. And then minus the derivative of 0.6x squared, we bring this 2 down, multiplied by 0.6, you're going to get 1.2. Copy the x over to the 1 less power. It'll be x to the 1, or just x. So c prime of x, or your marginal cost function, will be 90 minus 1.2x. So here we're going to evaluate c prime of x. I'm going to write this out. Evaluate c prime of x at the number previous to 21, which is in this case 20. So we're going to evaluate c prime of 20, not 21. So c prime of 20 is this, 90 minus 1.2 times x, which is 20. So I'm using that marginal cost function, substituting the x with 20. And this will give us, in dollars, 90 minus 1.2 times 20. That would be 66. Okay, so that's the marginal cost for producing the 21st food processor, $66. Okay. All right, example 5 is this. Find the profit function if cost and revenue are given by c of x is equal to 153 plus 3.2x, and r of x is equal to 2x minus 0.03 x squared. Okay. So here we're just finding the profit function. We're not having to find the marginal cost, just the profit function. And according to this, the profit function, P of x is equal to the revenue minus the cost. So in this case here, P of x is equal to the revenue was 2x, revenue function was 2x minus 0.03 x squared minus the cost, which was 153 plus 3.2 x. Notice that function c of x is in parentheses because I'm subtracting the whole thing from r of x. Now, if I simplify this, p of x is equal to, bring down to 2x minus 0.03 x squared, distribute the negative over 153 plus 3.2x, you're going to get minus 153 minus 3.2 x. And then combine like terms and put these terms in descending powers. I'm going to put the negative 0.03 x squared in front. 2x minus a 3x. 2x minus 3.2x will be a negative or minus 1.2x. Then bring down the minus 153. So this is your profit function. P of x is equal to negative 0.3 x squared minus 1.2x minus 153. Okay. All right, next we'll look at marginal average cost, revenue, and profit. This one's a little bit different here because we have the key word here, average. Here's some definitions here. If X is the number of units of a product produced in some time interval, then your average cost per unit would be this. C bar of X. Sometimes they use the bar to represent the mean or the average. So C bar of X will be this. Your cost function divided by X. And then the marginal average cost would be C bar prime of X. That's just your derivative of your average cost per unit. That's just the derivative of C bar of X. Okay. And then for the marginal average revenue, if X is the number of units of a product sold in some time interval, then the average revenue per unit would be R bar of X, which is R of X divided by X. And then for the marginal average revenue, you just take the derivative of your average revenue per unit function, R bar prime of X. That's the derivative of R bar of X with respect to X. And finally, if X is the average number of units of a product produced and sold in some time interval, then your average profit unit would just be this. P bar of X would be just your profit function divided by X. And then for the marginal average profit, we just take its derivative. So P bar prime of X would be just the derivative of your profit function, P bar of X, with respect to X. Now, I do need to warn you about this. When you're calculating marginal averages, you must calculate the average first. In other words, you must divide by X and then get the derivative. So if you change the order of this, you will get no useful economic interpretation. So make sure that you divide by X first to get the average for each one of those, the marginal average, and then you take the derivative. All right, take a look at example 6 in this case, just to show you what this means, what I mean here. Let's say I want to find the average cost if cost and revenue are given by C of X is equal to 168 plus 4.5X and R of X is equal to 8X minus 0.07X squared. Now you're told to find the average cost function. So the only thing we're going to be focusing on is this right here. Your cost function, C of X is equal to 168 plus 4.5X. So let's first find the average cost. And that is C bar of X. And that's, of course, the cost function C of X divided by X. And C of X is that 168 plus 4.5X. The whole thing is divided by X. Now, these two terms are each divided by X, so I can put this up as 168 over X plus 4.5 over X. It should be 4.5X over X because these X's divide out. So you're going to be left with just 168 over X plus 4.5. Okay. So that would be the average cost function for this situation. All right, Example 7 is to find the marginal average cost. Find the marginal average cost function if cost and revenue are given by C of x is equal to 151 plus 2.2x, and R of x is equal to 5x minus 0.01x squared. All right, so first of all, let's find the average cost. Okay, that's the first thing we need to do here first, which is, of course, C bar of x, and that's equal to C of x divided by x. And your cost function is the only thing that we're going to look at, where C of x is equal to 151 plus 2.2x. So C of x is 151 plus 2.2x, all divided by x, which I can break this up as 151 divided by x plus 2.2x divided by x. So I'll just bring over the 151 over x, and in 2.2x divided by x, the x is divided out, you're left with just plus 2.2. So that's my average cost function. But they want the marginal average cost function. That's, of course, taking C bar prime of x, which is in this case the derivative with respect to x of C bar of x. So the derivative with respect to x, C bar of x is right here, 151 over x plus 2.2. But that 151 over x, I'm going to write that using exponents, negative exponents. So the derivative with respect to x of 151, pull the x out of the denominator, change the exponent of 1 from positive 1 to negative 1. So the derivative with respect to x of 151, x to the negative 1 plus 2, we just take the derivative of each term. And 151 x to the negative 1, if I take its derivative, I bring that negative 1 down, multiply by 151, it'll be negative 151. Copy the x over to the 1 less power. Negative 1 minus 1 is negative 2. And for the derivative of 2.2, the derivative of a constant is 0. So I have negative 151 x to the negative 2. And using positive exponents, I have negative 151 in the numerator. The x will be in the denominator, but that exponent for the x will be positive. So the negative 151 over x squared. That would be the marginal average cost function for this situation. Okay. All right, in example 8, we have some applications that are related to these type of functions here. The total cost in dollars of manufacturing X auto body frames is C of X is equal to 60,000 plus 900X. Part A, you're going to find the average cost per unit if 250 frames are produced. Part B, find the marginal average cost of it at production level of 250 units. Part C, use the results from parts A and B to estimate the average cost per frame if 251 frames are produced. All right, so we'll start with part A. I want the average cost per unit. So the average cost per unit, that's going to be C bar of X, which means I take C of X, the cost function, divide that by X. And the cost here is that 60,000 plus 900X. So it'd be 60,000 plus 900X. Whole thing's divided by X. So if I simplify this, it's just going to be 60,000 divided by X. If I put this up separately, divided by 900X divided by X. Here your X's divide out. So that means I'll have 60,000 over X plus 900. Now we're going to use that to find the average cost per unit if 250 frames are produced. So that means X is 250, so C bar of 250 is just this. We substitute the X in that function, in that average cost function, by the way, with 250, so it'll be 60,000 divided by 250 plus 900. So 60,000 divided by 250 plus 900 gives me $1,140. So the average cost per unit, if 250 frames are produced, would be $1,140. Okay, so that's part A. Part B is finding the marginal average cost at a production level of 250 units. So that means here, we need to find C bar prime of X. That means marginal average cost, we have to take the derivative. And of course, that is the derivative with respect to X of the average cost function, which means the derivative with respect to X in the average cost function was this, 600 divided by X plus 900. I mean, 60,000 divided by X plus 900. But of course, I want to write this using negative exponents. So this would be 60,000 X to the negative 1. Take the X out of the denominator. The exponent for the X is the understood 1, but it becomes negative when you take it out of the denominator. Plus 900. All right, so the derivative of 60,000 X to the negative 1 would be this. Bring the negative 1 down, multiply by 60,000. It would be negative 60,000. Copy the X down to the 1 less power. Negative 1 minus 1 would be negative 2. The derivative of 900 is like the derivative of any constant. That's going to be 0. So if I write this using positive exponents, that would be negative 60,000 over X squared. Okay. I'm writing it again using positive exponents. Now, for 250 units, in this case here, your X will be 250, so C bar prime of 250, we use this and just substitute your X for 250, so it would be a negative 60,000 divided by X, which is 250, and that's squared. So negative 60,000 divided by 250, and that's squared, will be negative 0.96. So the marginal average cost at a production level of 250 units would be like a negative 96 cents. And then part C, you're to use the results in parts A and B to estimate the average cost per frame if 251 frames are produced. Okay, so here's what we got. C bar of 251, that's going to be C bar of 250 minus 0.96. So we're estimating the average cost per frame. So C bar of 250 was 1140 minus 0.96. So 1140 minus 0.96 would be approximately $1,139.04. $1,139.04. All right, so this represents the estimate of the average cost per frame if the 251st frame, if 251 frames are produced. Okay, and finally, example 9, the profit in dollars from a sale of X lawnmowers is P of X is equal to 20X minus 0.02 X squared minus 650. You'll want to find the average profit per mower if 70 mowers are produced. Then find the marginal average profit at a production level of 70 mowers and interpret that result. And then use the results from parts A and B to estimate the average profit per mower if 71 mowers are produced. Okay, so let's take a look at this here. Starting with part A, we want the average profit. And we're given the profit in dollars, by the way, so we want P bar of X, which is, of course, P of X divided by X. And your P of X is at 20X minus 0.02 X squared minus 650. The whole thing is divided by X, which means each term in the numerator is divided by X. So 20X is divided by X minus 0.02 X squared is also divided by X minus 650. That's divided by X. So in this case here, your X's divide out there, you're left with 20 minus one of the X's in X squared divides out with the X in the denominator. You're left with 0.02 X and then minus 650 over X. So that would be your average profit function. Now let's find the average profit per mower if 70 mowers are produced. So we had to do P of 70 and substitute 70 for X in this average profit function. So this will mean 20 minus 0.02 times X, which is 70, minus 650 divided by 70. This is going to be in dollars and cents. So We're going to do 20 minus 0.02 times 70 minus, I'm going to put this in parentheses, 650 divided by 70, close parentheses. To two decimal place, that would be approximately $9.31. So the average profit per mower, if 70 mowers are produced, would be $9.31. So that's part A. Part B is to find the marginal average profit at a production level of 70 mowers and interpret the results. So in this case here, we want the derivative of that average profit function. That's P bar prime of X. That's just the derivative with respect to X of the average profit function. So the derivative with respect to X is just going to be this. We use this right here. 20 minus 0.02 X minus. Now 650 over X, I'm going to use negative exponents, but I'm writing it as 650 X to the negative 1. Because I'm taking the derivative of this with respect to X. So in this case here, the derivative of 20 is 0. The derivative of a negative 0.02x will be negative 0.02. The derivative of minus 650x to the negative 1 would bring the negative 1 down, multiplied by minus 650 will be plus 650. Copy the x over to the 1 less power. Negative 1 minus 1 would be negative 2. And of course, I can write that using positive exponents. That'd be negative 0.02 plus 650 over x squared. And then find out what P bar 70 is. P bar prime of 70. That's the marginal average profit at a production level of 70 mowers. So we just substitute the x here with 70. So it'd be negative 0.02 plus 650 over x, which is 70, and that's squared. So negative 0.02 plus, in parentheses, 650 divided by 70, and I'm going to square that, right parentheses for that. To two decimal places, it'll be approximately 11 cents. Now, what does this mean? It means this, and here's the interpretation of that. At the production of 70 mowers, the profit increases at a rate of 11 cents per mower. So at the production of 70 mowers, the profit increases at a rate of 11, or increases at a rate of 11 cents per mower. Okay, and finally, you're going to use the results of parts A and B to estimate the average profit per mower if 71 mowers are produced. That means one additional mower after 70. So in this case here, we're finding the average profit. So that means that P bar of 71 is the average cost of producing 70 mowers plus the rate of 11 cents. That's from part B. So in this case here, the average cost of producing 70 mowers was $9.31 from part A. plus 11 cents. That was the marginal average profit from Part B. So if I add those two together, you should get $9.42. That amount represents the estimate of the average profit per mower if 71 mowers are produced. Okay. So that does conclude this video in section 2.7, deal with marginal analysis in business and economics. Feel free to reach out to me if you have any questions about any of the problems that I've worked out in this video or any of the homework problems in my math lab.